Hey folks, sometimes you ask questions on our analysis use forum that are not easy to answer, and I see some, educational potential in all this. Here we are dealing with a question that was originally posted on our forum in Chinese, then the guy translated it into English, and then it starts to feel like probably something is not working with the IVTK tools, IVTK interface of OpenCascade. For those of you who do not know, OpenCascade provides this IVTK interface to deal with VTK visualization toolkit front end. And well, back in the days, this IVTK tools was developed by our team. We tried to make a bridge between OpenCascade shapes and VTK, and this is how this interface appeared. Today, in our analysis use team, we do not use these interfaces anymore because we needed some more flexibility than it can provide. But okay, well, since it's a part of OpenCascade, we need to be sure that this part works. So let's try to make use of it. Let's try to see what's going on with all this code over here. First of all, we need to configure OpenCascade to use VTK bridge. And for that, well, actually I'm going to use our fork of OpenCascade, which is essentially version 7.6, and VTK that we have is VTK 8.2, which is not exactly the versions used in the original report, but let's first try to reproduce it with the versions that are easy to compile, because otherwise I'll have to rebuild both libraries from scratch, and it's going to be very time consuming. So in OpenCascade CMake, what we have to do is we have to enable this useVTK flag, and after that we will have this IVTK bridge enabled, and also we need to make sure that VTK is available somewhere in our libpack. So here we see that okay, VTK version 8.2 was successfully found, because actually already have it in our libpack. Although we do not use IVTK bridge, we do use VTK, and that's why OpenCascade can easily be configured with it as well. Also, I think that it's not a big deal to have VTK enabled by default. I mean, especially in our context, why not? So I'm going to keep this useVTK enabled not only for the sake of this particular exercise, but I'll probably leave it like this for the rest of our life cycle with this version of OpenCascade. Alright, so configuration is done. What we see here is that VTK library was automatically found together with Qt. So let's leave it like that, generate the project and proceed with the build process. In the Solution Explorer you can also easily find that this bridge is now enabled. For that you go to Visualization Filter, and here you see this TK IVTK. So these are the packages that are relevant for VTK-based visualization. But let's not discuss its architecture as of now, and rather just go and build OpenCascade with this functionality enabled. After OpenCascade compilation, what I'm supposed to do is I'm supposed to install the project to copy all the binaries and header files and lib files to the destination directory where I can link my projects against OpenCascade. But before doing that, let's launch Draw. Draw.exe is, as you can see here, the startup project, so I can just run it from here. So as usual, let's start with loading all the plugins, and especially what I'm interested in is I'm interested in loading these, which is VTK interactive services. And now I can use commands like IVTK. You see there are quite some commands like IVTK AXO, IVTK camera, clear, init, and whatnot. So let's now create a box shape to be a unit box, and then we go for IVTK init. This command should open up this VTK based viewport. It's still OpenGL viewport, but now for rendering we use VTK library. And now I can go for IVTK display A. So here is the box visualized with the means of visualization toolkit. IVTK set disp mode A1 is for shading, so selection works, shading works, interaction works. So basically, I'm pretty sure that everything is configured properly, and we can close the session. Now I'm going to install OpenCascade with the VTK bridge enabled and give it a try in a separate environment of analysis CTUs or in the scope of like separate executable, namely outside of OpenCascade's native solution. Alright, so now I made sure to build and install OpenCascade in both release and debug configurations, and I'm going to get back to my working environment, which is for me daily analysis CTUs, and give a try to the problematic code posted by this guy on the forum. So in analysis CTUs, this project, why I'm using it is because this project is already configured to use OpenCascade, so I have all required linker and compiler options specified correctly, and now my usual trick is to go to ASI.exe, and here in the main function in exe_main there is a little magic macro VTK test, which is by default undefined. But if I go and define this macro, then what will happen is instead of initializing the analysis CTU's own infrastructure, instead of creating the main window and everything else, what will happen is some test code that I usually grab from VTK examples will be compiled instead. So this code over here in the else branch of this macro definition will get compiled. And what I see here basically is the code grabbed from VTK examples. So here for now what we see is this little example. You see it's like a native Win32 widget window, and we have some slider that controls the decimation for sphere. So basically this example I just took from the official VTK website. But alright, so instead of using this code, this external example, what I'm going to do is I'm going to grab this piece of code provided by the guy from the forum. All the include statements, well, I'll leave them as they are because it will be just easier. So let's eliminate everything from here. Of course you can do this same thing if you just run, like bare minimum application. If you configure everything from scratch, you can start with like a console application if you will. For me it's just easier to put it this way, and this is what I'm normally doing when I am supposed to try things out without investing too much time. So what we see here, okay, so we have some commands like import step file, then we have supposedly like a namespace or a class name DMU CAD reader. DMU is probably digital mockup or something like that. We have some member, but we don't have a class definition, so we don't have anything. Well, I mean, this code is of course not runnable the way it's written, so I probably have to start with putting together a simple main function like void main. Well, let it be this way. I'm not even supposed to return anything here, assuming that according to the standard this return 0 will be just added by default. So we have this function setActor, where is the end of this function? Somewhere around here. So I just probably leave this function as it is and remove this kind of a namespace setActor. Alright, so I'm not sure what this function actually does, but we need to compile it first in order to give it a go. So basically there are some missing includes, and you can see that actually those IVTK tools, they are coming from this IVTK bridge of OpenCascade. So this is something you're supposed to use. So this shape data source, if I remember well what it does, it takes the top-of-the shape that is supposed to be passed as an argument here. So it can be like top-of-the shape, and I'll be using this shape instead of M shape. This IVTK OCC shape, I assume that it's a handle of this IVTK OCC shape, which is like a wrapper over the shape. So we have this VTK data source over here, and we need to feed this data source with the shape, but according to the architecture of IVTK bridge, you cannot pass this shape directly, you rather have to pass it as a smart pointer for this wrapper class. I think it's a little bit of like an overcomplication, but this is the way it is, and we have to respect this interface. Then I'm not sure what is generate ID. Well, I think it's probably some unique identifier of a shape. So we need to have a function like this. Let it be just one. I mean, you can also use some business logic, if you will, like here. So we set this ID, which will be the, I would assume, like a unique identifier of your shape on the screen, and then you have a smart pointer over the display mode filter. So this is how you switch between shading and wireframe display modes. So we effectively build this pipeline with the source over here, and after that we apply the display mode filter. After that we can do something else, like we can also apply some, native VTK filters here, like VTK transform or something else, and all these has to end up with a VTK actor. So the things on this diagram that I rendered in red color were specific to IVTK bridge, while the things that are rendered in green color, they are native VTK things. They are like according to the architecture of VTK itself. So we have this pipeline that we are trying to put together, and what we say here is let's allocate a filter, let's set it like a display mode of shading, and then we configure something else. We initialize the data object of VTK, which is polydata, which is pretty standard VTK data object. We initialize the mapper. We say, okay, we want to visualize colors on this mapper, and then we have an actor. Alright, so this is a decimation filter, this decimation algorithm that is provided by VTK, pretty powerful one. We also used it in one of our projects back in the days. So what we are doing is we are applying this decimation filter. And then we set a mapper for the actor. So I think what we are doing here is we are trying to initialize this polydata with the source of the shape, like the meshes that we obtain from the shape. So, okay, let's leave it for now like this. And we have this actor that I guess has to be passed probably as an argument, like VTK smart pointer, VTK actor. So let it be this. Assuming that this actor will be allocated from the outside of this function, and here we are only setting the mapper to this actor, which is like pretty clunky architecture, to be honest, but alright, maybe it should be like init actor, because this is how you're supposed to name thing that is going to accept the already allocated actor from the outside and set a mapper, like initialize the pipeline. So effectively what you have is you have an actor. This is like an object that is going to be rendered on the screen, right? So what is missing is like this connection. You have to connect this actor to the mapper, and this mapper is connected to everything else, like to the source and then all the filters, filter 1, then filter 2 and whatnot. So what this function does, this init actor, is actually sets this connection over here. Otherwise your actor is not connected to anything. Alright, so I would assume that this is what we are doing here. Then we also initialize some properties, like the properties of lightning, specular, ambient and diffuse. Then we associate the shape source with the actor, which is a little trick normally used in interactive selection. Then you pick on a shape, you can normally access immediately the shape source, and from the shape source you can probably also access the top-of-the shape as such. So this is some of the things that you normally see when you use like this IVTK bridge. You associate the actor with the shape source directly, and then there is some VTK assembly. I can say that I never used this VTK assembly before, have very little idea what it's all about, but let's just follow the flow of this code and make it compilable in the first place. So I assume that this was the step 1, right? And I also probably have to restore some of the basic infrastructure just to initialize the scene, right? So initially I had this main function, and okay, here's an actor mapper, renderer. So basically what I want to have is the renderer, the render window interactor, actor, and this invocation from here. This is like the basic code that you need to have in order just to use like VTK rendering facilities. Actor is not here yet, and we can allocate it basically with VTK new, VTK actor. So this is how you can allocate a VTK object instead of like writing it in more verbose way, like VTK smart pointer, VTK actor assigned to smart pointer actor new. So instead of writing this, you can just keep it brief and write it like this. Let's leave the background to be the default, and okay, here we have an actor and we can init our actor with the shape. So what is the shape? Let it be just grep rim API box, because why not? Or we can also like read it from the step file if you want. Let me keep it simple. Make box, and here we can specify the dimensions of the box, assuming that its bottom left corner is located at the global origin. So this is our top.ds shape, make box, init actor, shape, actor. Alright, so probably here I have to pass a pointer to the actor. Yeah, and this way it would work well. VTK new is, yeah, can be dereferenced as a row pointer, so I have to use it that way. And do not pass here the smart pointer, because I'm not going to like take the ownership of the shared object whatsoever, and using the row pointer is just fine. So we have this then, but before we go there, let's probably try to compile what we already have, because it's already looking like something compilable, right? And I'll also put a breakpoint here. Well, okay, it seems like this function, like init actor, what it does, it also like adds the actor to the renderer, which is probably to be moved out. Okay, we have also this VTK assembly here that is supposed to be passed to the renderer, right? So probably I can just pass here the renderer as well, although I do not like this architecture. Okay, renderer, let's put it like this. So what would happen is, okay, we allocate this actor over here, so we create a new object, and after that we use this init actor. All right, let's finally rename it to add actor, because I'm not happy with this init actor anymore. Add actor will initialize the pipeline, it will connect the actor to the data source, and after all this, it will also add the actor to the renderer. And the renderer is my renderer here. Now it should be compilable at least. Alright, so now I have linker errors everywhere saying that, okay, although I compile OpenCascade v VTK support, I do not link against IVTK libraries. So in the CMake lists of my executable, I have to add this library as well, saying, okay, I also want to use this IVTK bridge. Finally it compiles and we can run it. So now we are here, we have new renderer, render window, all this code I just took from the previous example. Now we have this shape and we basically add an actor. So let's step into this function. Shape is not null, we construct the data source, we construct a wrapper over our shape, we set the shape wrapper to the shape data source. We have this ID as 1, we set the ID, we set up this display mode filter, initialize this mysterious polydata. Alright, it seems like what we are doing here is, if we see that this shape is very, very complex, like it contains thousands of polygons, right? Yeah, like more than 200,000 polygons. When what we are trying to do is we are trying just to decimate it. This is probably why they call it DMU, because DMU is like a digital mockup, and normally in DMU scenarios what you want to do is you want to simplify your models as much as possible. We did the same thing in CAD processor. We now have our simplification SDK for the same thing, and basically, yeah, they decimate the meshes, and it seems like, okay, after they decimate the meshes, they put back the decimated meshes to the mapper. This will, of course, ruin the topology of the part, because this decimator doesn't respect any edges of the part. it just does this cross-boundary simplification of the model, of the meshes. Instead of doing that, what you might want to do is rather defeature your part, like remove all small holes, like logos and small features, cavities and whatnot. And instead of like using this decimation, you can rather go and just remesh your model with brep mesh with some, coarser parameters, and it will bring you to a, like sort of like decimated model. And this is something I would prefer to do. But anyways, this decimation did not happen. We create this VTK assembly. We add a part to this assembly, which is asim. This is just like a scene, like a tree of parts to visualize. We add our assembly as an actor to the renderer, and there we go. Now we render, initialize, render, and start interaction. So you see now we are here, and this is our box. All right, so I assume that it kind of works. What's the problem? I need to use VTK assembly. So it seems like the real problem is not to visualize something, but rather to use shape picker. So this is working just fine. And that's why we have to go for the step 2. This is another bit of refactoring. Okay, so what do we have here? Apparently, according to what's written here in this command, we are supposed to inherit from VTK command, which is like a callback mechanism of VTK to re-implement the execute function. So this is what you are supposed to do when you inherit from VTK command. And this time we cannot avoid using classes because we need to inherit from VTK command, and that means that we have to use a class. Okay, let it be like DMU cat picker. So this is something to react on the picking events. We have this 2 magic definitions coming from the VTK architecture, and then we have a constructor and destructor. Okay, we have a couple of private constructor, which is like an assignment constructor and assignment operator that we do not want, and we just delete them forcibly over here. And this is the real thing. This is the execute function that we are supposed to customize. And here we have 2 pickers. One is cell picker, another is the shape picker coming from OpenCascade. So apparently the guy was experimenting with both. Although you normally either use like VTK cell picker or iVTK tools shape picker. So VTK cell picker has to be included. Yeah, and this one is coming from OpenCascade, so it has to go here. Shape picker. Yeah, we have this implementation of the execute function over here. Well, I'll just take it out from this place and implement it right here. So let's try to figure out what it's all about. We have render window interactor, that is the color. So it's just like this little object that is passed by VTK over. Then we have render window that we can access from the render window interactor. Then we have the clicking position, so this is where basically the click happened. Then we have the renderer that activated the clicking event, and then we use cell picker in order to pick the position. So we have this click pause and we pick the position, then we have a camera, we have this pick position in the world coordinates. The mechanics of this picking will be just ray intersection, so we are going to cast a ray from the camera to the clicked position, and if we hit some cell ID, like a little component of the VTK actor, then this cell ID would not be equal to -1, and we will fall into this if statement. And probably already here I want to have like some cout, like picket cell ID. And we can also print the cell ID if we want, although it would not help much as long as we do not have any semantics bound to the cell ID. Then we have this set cat selection mode, although, well, this function is not implemented here, and it means that, well, that's pretty interesting, because what happens here is that we first use cell picker in order to identify that we pick some cell, and after that we delegate the invocation to shape picker, and we pass the same clicking position to the shape picker, trying to access the picked actor. So that's pretty interesting, but what is set cat selection mode? Let's comment it out for now. And these 2 guys, I think they have to be initialized in the first place. Well, the guy did not provide any initialization mechanics for this, so I'm assuming that I can just go for VTK new and just initialize both, like there we go. So I'm curious, like we will ever get here, because this is the main question. And well, okay, we have this rubber band 3D. And I think this is the real problem. Like during the execution, the shape picker is unable to obtain the selected VTK actor. So let's leave this command from here, and I'll be using iron. Iron, I think it's, what is iron? It's I think it's render window interactor, but I might be mistaken here. Am I? So we had an observer for our render window interactor saying, okay, on the left button press event, when we click, we have this cat picker, and then the mouse is moving. We have the same cat picker actually, so the same logic will be used. So what is cat picker? Cat picker is this little class over here, DMU cat picker, and yeah, here we need to put it like this and create this callback with VTK new. Alrighty, so let's hit a breakpoint over here, compile it again, and see if we are ever going to enter this callback function, which will already be like a little bit of success, right? Okay, new is not defined. We have problem with this new, which I assume is something like return DMU cat picker. Would it work that way? I'm not a big specialist in VTK, so you might want to Google it, but I think that might work. Alright, so now we have all these hide class member. Well, that's a pity. It means that I actually, instead of like initializing the class member, I just create like a local variable of the same name. So that's not going to work, and instead I'm going to go like VTK smart pointer, VTK so picker, the new, and yeah, here the same thing, VTK smart pointer, also new, and some unused parameters. That's probably less of an issue. And like, okay, destructor does nothing because I initialized those two guys as VTK smart pointers, although they're also smart pointers here in the member class declaration. It means that I'm not going to have any memory leaks whatsoever with all this stuff, and we can try to run it. What will happen is when I move the mouse pointer, you see that I am here in this get cell ID, pick cell ID. So actually the picker works. We have just a couple of triangles, and that's why we have like two cell IDs whenever I move mouse pointer on one side of a cube. So this selection logic seems to work well, and I think that the claim here, the real problem is that this shape picker does not really work, and that's an issue, right? We have this actor collection and num is 0. So that's probably the claim, like this actor collection is just 0. So let's print the number, and if I remove these diagnostics, then that's probably the reproducer, the final reproducer, but to be honest, I would assume to have just grabbed from the forum. So we spent, I don't know, like 40 minutes trying to kind of reproduce the issue. So if you guys ever want to get some assistance from our team, please value our time and provide the reproducer so that we can just go and run it, not like spending like 1 hour just to compile this whole thing. That's not okay. Okay, so what we see is whatever I do, I always have like 0, always have 0. So probably the issue is that I should not use this VTK assembly and instead just use the actor of the shape itself, right? So what will happen if I just go and change it like this? I mean, visually it's the same thing because we do not have this assembly, and it still does not work. So it seems like the issue, at least for now, it's not in the use of the assembly. It's probably in something else. Like we also had this cat selection mode, which is something we should probably take a look at. And in order to know how to initialize this shape picker with the selection mode, we probably have to go into the implementation of this IVTK bridge, because in IVTK bridge we have this IVTK set cell mode or something, which is the draw command that we can launch we can use from the console in order to set like a selection mode to our actor, to our picker. So this is the implementation of the commands. We have an actor. Okay, we have this get picker and then set selection mode, and we can say, okay, for this actor we want to set like a shape selection mode. That's pretty interesting because we have to set this selection mode per actor, as it seems. Let's give it a try. We can, as long as we have a shape picker initialized over here. Well, it's also not super convenient because I do not have much control over this. Well, what I do not want to do is I do not want to set selection mode here in this execute function, because this function will be executed like thousands of times as long as I move my mouse cursor. So what I would rather prefer to do is I would prefer to set the cell picker properties after they got initialized, and for that I probably have to have like an accessor, right? So let it be just like a smart pointer. Get, well, it wouldn't be a cell picker. I would prefer to use shape picker instead. Get shape picker, because this is the shape picker that I want to configure. Shape picker. It can be const. It can also be like a const reference to the smart pointer, because I'm not going to modify the smart pointer as such. I want to modify the shared object. And let's return this shape picker. And by the way, why not we use here m prefix as long as we have it? For the cell picker, it should be also here, I would assume. Alright, so now that I have this getter, I can use this get shape picker and set selection mode that I want right after I initialized the get picker. So get picker, get shape picker, then set selection mode. It seems like I can specify the selection mode, not like being specific about the actor what I want to use. That's nice, because I have no idea about the actors when I do this. And let's see if it changes anything in the behavior of our example. So you see that it did not help. Like the number of picked shapes is still 0. So I'm curious what actually happened, why, and shouldn't we finally go deeper and put a breakpoint right here? The only thing is that when I'm hitting this breakpoint, I want to be sure that the actor is actually selected. Probably remove this breakpoint for now, just zoom in like this, so wherever my mouse pointer is, I will pick the shape, and there we go. So let's see. So we are picking the coordinates. The coordinates seem to be something, at least. We initialize the picking process. Well, something coming from the abstract picker mechanism of VTK, which I'm pretty sure we just do not care about. Then we start the picking event and we invoke this event. So if there is some observer that is listening to the start pick event, it will be called. We initialize the renderer, and I think the magic happens here in this function do pick implementation. So let's get into this function. We set the renderer, poly selection is false, rectangular selection is false, and then we have this picker algo. We are already in IVTK tools shape picker, and we are delegating this invocation to OCC picker algo, which is the instance of IVTK OCC shape picker algo. Alright, so probably it's a modular thing, like if you want to implement your own picking mechanics, you can do it if you will. Clear picked. Seems like we are just cleaning up the internal state of this picker algorithm. And then we have a viewer selector. So basically here we are not using VTK anymore, or do we? Okay, we still have some viewer selector. All right. We have mouse position. We initialize the view. And then we build selecting volume. So finally we get out of this IVTK breach and we fall into this select manager viewer selector. There the selection mechanics is entirely based on bounding volume hierarchies. So it's not anymore related to VTK as such. Now it's all about the selection mechanics of OpenCascade. So let's put a breakpoint here in the place where we are using some bounding box related mechanics, just to see if we ever get here. Because we essentially traverse the bounding boxes over here. It seems to me that we just never get into the bounding box selection logic, which is like pretty weird. It's pretty weird. Well, probably I should set the selection mode after I set the renderer, because my assumption here is that the actors that we are going to iterate over were taken from the renderer, and we should call this function after they set the renderer, because otherwise we wouldn't have access to the actors. Now we have this box. Alrighty, so we are starting to get closer, because we are already in the BH filtering mechanics. Here is our console, and you see like the number of OCC peak shape is 1. Yeah, you see now it works. What I'm curious about is what will happen if I just go and add this assembly instead of the actor, because I'm assuming that it would not work. But, well, actually it seems that it kind of works. I don't know why it says like I have 2 peaked shapes as of now. So this is probably something to debug further. So this is something we can potentially check. At least it means that it works. I mean, conceptually we have some like non-zero number over here. And the question is, how do we iterate over the collection of actors? So we are supposed to put together a little while loop like this, saying, okay, we have an actor collection. This is our, let it be actor. And can we just print it or something? Get class name. Well, why not? Let's trace what will happen. So if I move the mouse in the empty space when nothing is picked. And here, okay, I have this VTK OpenGL actor, which is, well, not super informative, to be honest. So let me just print the address of the object that we are adding to the renderer. And add it, well, let it be like shape actor, and then let it be like assembly actor, like VTK assembly. So both, this actor is a pointer to my actor, which is like a row pointer, and this assembly is a smart pointer. So if I want to use it, I would rather go and get like the row pointer out of it. So yeah, we see like some memory addresses. These are different, like this one and this one. These are like 2 different addresses, 2 different objects. And now, like, let's use the same diagnostics over here, and let's give it another try. So what we see here is that actually the assembly actor is not even involved. So we always pick this actor, like the shape actor. So what it finally means is that the presence of VTK assembly doesn't mess anything up. It's like leads to a little strange result, like, okay, we have this actor selected twice. In the worst case, you can work it around just by checking that you are not dealing with the same actor more than once. Or ideally, as long as we have all these in open source, we have VTK open source, we have OpenCascade open source together with this IVTK component, you can just go into the sources of IVTK and just try to understand why the heck this actor is like reported twice. I think you'll figure it out. And for today, it's already like a little bit too much for me. I mean, we spent like, I will edit this video, but all in all, I spent like about 2 hours, like just trying to understand what's going on. So I think let's stop here. And if something is still unclear, just let me know. Also, you can let me know what you think about this very format when you send some problematic code and we try to figure out what's going on, how to fix it, what are the hidden surprises of using one or another function in OpenCascade ecosystem. So let's be specific, it should be all about OpenCascade and modeling. So I hope it all makes sense, and see you next time.